Okay, so we ended on let me check. Okay, so we ended on question 2b. So basically this is part 3 and we are yet to continue where we ended from. So question 3 reads, a virus attacks a single user's computer and within 1 hour embeds itself in 50 email attachment files sent out to other users. So using that information, let's start analyzing this question. Okay, so it says by the end of the hour 10% of these have been opened and have infected the host machines. So keep in mind that a percent is of 100. So if we say 10%, it means 10 divided by 100. So that's one thing we need to understand. So after you do your calculations, you have 0.1. Okay, so now these 0.1, the 10% you are seeing, we are supposed to say 1 hour 1 hour is equal to 50 emails. So 50 emails, as you can see from that question, and we are saying 10% of these have been opened. So if you multiply that 50, if you multiply that 50 by 0.1, you get 5. So basically it means 10% of the 50 emails which were opened should be equal to 5 emails, because as you can see, if we say 50 times 0.1, that's where we are getting the 5. Okay, now the question goes on and say, if this process continues, how many machines will be infected at the end of 5 hours? So remember, here we had 1 hour is equal to 5 emails, because 10% we have already done that. So here it's more like if we have 5 hours, it's equal to x. So if we cross multiply, you can see that it will be 1x here, then it will be 5 times 5 for the emails. So if you get rid of the 1 by dividing it both sides, you remain with x, then 5 times 5 is 25. So following the question, it means that number of infected machines is equal to 25 based on our calculations. So let's continue. So the question says, can you find a formula for the number of machines infected after n hours? So as you can see, we said hours such as n hours should be equal to 5 emails, or 1 hour should be equal to 5 emails. 1 hour should be equal to 5 emails. Then n hours, which we don't know, should be equal to okay, so should be equal to x, as we said. So basically, if you can see, we have x is equals to 5n, because 5 times n is 5n. So we can have something like this, but to simplify things, here we mean hours times emails, number of emails, for us to get those formulas we are coming up with. So that's the actual formula, but the answer should be 5n, and the other answer should be 25, number of infected machines, formula 5n. So that's it for question 3a. So if you want to prove, remember that n represent hours. So to get number of infected machines, if we had 5 hours, based on the previous example, you see that it will be 5 times 5, which will be 25. So if we get like 10 hours, it will be 5 times 10, which is 50, number of infected machines. So that's it. So question 3b1. Use the RSA encryption algorithm. Let P be equal to 3 and Q be equal to 5. Then N equal to 15 and M equal to 8. Let E equal to 11. So basically RSA is a public key encryption algorithm. So the R stand for Rivest, who is one of the people came up with this algorithm. Then S Shauma and A Aldomin. So if I gave the wrong pronunciations, but basically those are the three guys who came up with this public key encryption algorithm. So we have one which says compute D. So the formula to find D basically is ED minus 1, then divide by M. So this has a condition. Once you compute everything, this must equate to, it must give you a remainder of 0. So that's the key. After you plug in all the values, you must get a remainder of 0. So let's see how we can solve this. So basically our E, based on the this question, it's 11. So where there's E, we put 11 like that. Then D, we are trying to find D. So for now we will leave it blank. Then minus 1. Then divide by M, which is, so where is our M, which is 8, like that. So we will do that. So now here we need to list prime numbers which are less than n. So I'll explain. So let me do that. Okay, so since our n is 15, so we will list prime numbers which are less than 15, such as 2, 3, 5, 7, 11, and 13. So if you don't know how to come up with prime numbers, just know that a prime number is a number which is only divisible by itself and 1. Or in most cases, I just say a number which is when divided by 2, it gives you a remainder which is not 0. So for example, if I say 3 divided by 2, we get point something. So 3 divided by 2, we get point something. Or we can say it's that number and divisible by itself. So if you can see, you cannot divide the number apart from 1 and itself, including 5, 7, 11, and 13. So knowing that, now we need to use these suggested prime numbers to replace them here where we're supposed to put D. So after computing this and we get a remainder of 0, it means that that's our D. So let's do that. We go on the calculator like that. Then as you can see, we have 11, which is this. We have 11, which is this. Then here we have times D, which we don't know. Let me say it's 2. So it will be times 2, like that, equal, you get 22. Then we have a minus. So you say minus, then we have a 1. You say 1, then you enter. Now we have our M, which our M is 8 in this case. So you say divide by 8. So as you can see, we are not getting a remainder of 0 because it's not a whole number. So therefore, d is not 2. So we try for this, which is 3. We say 11, which is this, then times 3, which will act as our d, then we get 33. Then we say minus 1, we get 32. Then lastly we divide by 8, which is m. So once we divide by 8, which is m, we get 4. So 4, as you can see, it's a whole number, so meaning the remainder is 0. So this whole thing gives you 4 and it has a remainder of 0. So basically our d is 4. So we can say therefore d is equal to 4, as the question was stating, find d. So we are done. So our d basically is 4. Oh, no. sorry, I've made a mistake. This 4 is just the answer for this with a remainder of 0. But to get 4, we had to replace 3. So 3 was acting as our d, because 11 times 3 is 33. Then minus 1, we get 32. Divide by 8, we get 4. So 3 was representing d. So therefore d is equal to 3, not 4. So hope you got that. So let's proceed to the question, second question, which says find the code for 3. So now this would be interesting. So let's find the code for 3. So first of all, we need to understand the question. If they tell you to find the code for 3, it means that they want you to encrypt a letter which is at position number 3. So I'll explain everything and I'll give you the formulas for encrypting and decrypting. So don't worry, everything will be explained. So for this question, you need to make your alphabet look like this so that you know the position for each letter. So if they are saying the code for 3, as you can see, 3 is C. So basically we want to encrypt C so that people won't know that the actual message was C. So the formula for encrypting is, since when you're encrypting something which is in plain text, you get the ciphertext. So it will be ciphertext, which will be the outcome, is equal to the plain text, which is m, that message, then to the power e, which was the encryption algorithm used, then mod n. So let me explain the formula first. This C you are seeing represent the cipher where we are supposed to get the outcome when we encrypt the code, which is 3. Then M represents the letter which is being encrypted. In our case, it's C, because we are at 3. Then E represents the encryption algorithm for this process. Then mod n, it means we need to find the modulus for that given n, in our case, which is 15, for us to come up with C. Okay, why are we using modulus or mod? It's because we end up getting huge numbers, so we wrap them around to get numbers which are within the range of 26 for the alphabet. So let's start. Our C is just C, ciphertext. Then our M, as you can see, the plain text is 3, because C, or the code of 3, is actually C. So we just say 3, because we cannot compute something with letters. So I'll just say 3, not C. Then power. So E from the question, as you can see, it was 11. So we say 11, then mod n. So n basically is 15 for from that question, like that. So now we just need to go to our calculator, then say 3 power 11, like that. So we get this answer like that. then mod 15. So basically mod just represents divide, like you can just say as if you want to find the remainder. So the first process, we need to divide it by 15, first step. So you need to divide this answer by 15 like that, then you get that. So after getting that answer, now what you need to do is that you need to repeat this same answer but without a point, like that, just like your number. Then you say times 15, the same 15 used for dividing. So what I'll do here now is that I'll say 11809 without that dot 8, then times 15 to get the product. So I'll copy this. So that's our answer from that. Then we get that. Now we need to get back this first answer we had after finding the power. Then we need to subtract it from this new answer, which is this, like that. So as you can see, this part up to here and this are the same. So we only concentrate 147 minus 135, or we can say starting from here up to here is the same as from here up to here. So it's 47 minus 35. Without wasting time, it's 47 minus 35. So we get 12, like that. So on the alphabet, 12 is equal to what? So as you can see, it's L. So when you encrypt C, you get L, meaning someone won't able to understand what you have done. So let me repeat one more. This is the formula used to encrypt a certain message using RSA. So C represents a ciphertext, M represents a plain text being encoded, then E represents the encryption algorithm, then modulus N, the N you are given. So after replacing your M with the actual number, you power it to the given encryption algorithm. Then when you get that answer, you need to divide it with its mode. After dividing with its mode, you just consider the whole number like this without the dot. Then you multiply it by its denominator again to get another whole number. Then from that you can subtract the first answer after powering it with the last answer you had, in order for you to get the remainder, which is L. So let's hope that's clear. So now that we are done with 2, let's do the final one, which is 3. Okay, so it says decode your answer in part 2 to retrieve 3. So basically this same thing we just need to decode it. So we are getting our plain text, which is M for the message. So M is the actual message which we want, and we know it's 3 or C. So we are decoding it back. So we need the ciphertext. So the ciphertext power decryption algorithm, then mod N, just like that. So now we know our cipher, which is 12 or L, but I'll say 12. Then as you can see, our D was 3 based on our solution for 1, so it will be power 3, then mod N, which is just 15. Now if we say 12 power 3, what's the answer? So if we say 12 power 3 like that, so we get this. So after getting this, we say mod 15. So as I explained earlier, this is more like divide by 15. So we will divide this with 15, then get a new answer, which is this. Then after that, we need to write this as a whole number without a dot, then times the denominator. So we have 115 times 15 like that for us to know the remainder. Okay, so we have this now. Okay, so now we need to get the first answer we had after that power, then subtract it with the second answer we have like that. Okay, now if you can see, this whole part up to here is just the same with this, so it's more like 8 minus 5, which is just 3, or 3 can be represented as C. So basically we are done encoding and decoding, and I'm sure you have gotten some concepts for this. So this is Soko James representing KMU cybersecurity tutorials for first year students. So this is cryptography. Watch out for part 4, which will cover question 4A and B. See you.